Okay, this is the November 2019 paper 2 question on acids and bases. It says a hydrogen bromide solution HBr reacts with water according to the following balanced equation. There's your little equation there. It says the Ka value of HBr at 25 degrees is 1 times 10 to the 9. Then it says to you, is hydrogen bromide a strong acid or a weak acid? Give a reason for your answer. Well, you could do this from your own knowledge, but if you have a look here, the Ka value has got a positive exponent. So if you have a positive exponent on a Ka value, it means that the forward reaction is strongly favored, which means that you have a high concentration of hydronium ions. So this hydrogen bromide, it will be a strong acid because the Ka value is high, okay? And if a Ka value is high, it means that there's a high concentration of hydronium ions. Remember, with this definition, you have to put that there's a lot of ions because it's dissociated strongly. So we can also say it's got a high degree of dissociation, giving you a high concentration of hydronium ions. Write down the formulae of two bases in the above equation. Well, when you look at this and your mind goes, where's the base, I don't see a hydroxide ion, you have to remember the other definition of a base is a proton acceptor. So in this equation, the H2O goes to the H3O plus, so it has accepted a base. So the water must be acting as a base, and you know that water is amphoteric or an ampholyte, so it's accepting a proton to become a base. The other one is not so obvious, but it is in fact the conjugate base of the hydrogen bromide. So the other base is the bromide ion, because the bromide ion can accept a proton and it will then go back to hydrogen bromide over there. So those are your two bases. So now let's have a look here. It says to you, hydrogen bromide reacts with zinc hydroxide according to the following balanced equation. An unknown quantity of zinc hydroxide is reacted with 90 cubic centimeters of hydrogen bromide in a flask. Assume that the volume of the solution does not change during the reaction. The excess hydrogen bromide is then neutralized by 16.5 cubic centimeters of sodium hydroxide of concentration 0.5 moles per cubic decimeter. The balanced equation for the reaction is: calculate the pH of the hydrogen bromide solution remaining in the flask after the reaction with zinc hydroxide. So now the problem here is that you've got two things going on here. Remember, in all of these equations, you always have to find the moles of what you know. So what we know in this equation, the only thing we know for sure in this equation in the beginning is the sodium hydroxide. But we need to keep track of what's going on here. So I like to draw pictures. So if we have a reaction vessel or a beaker or whatever you want to call it, in here we placed the zinc hydroxide, okay? And then we also placed in here hydrogen bromide, okay? And there was 90 cubic centimeters here. And once we had this in the flask, a reaction occurred, and all the zinc bromide got, all the zinc hydroxide got turned into the zinc bromide salt, and we were then left with some HBr in here that was in excess. So this was the HBr initial, okay, and then after the reaction there was some excess, and then to this excess HBr they went and they added some sodium hydroxide. So this is now the second equation, okay? So they are asking you to find out, in this particular part, they're asking you to find out what is the pH of this solution after it reacted, after the zinc hydroxide reaction. So we have to go from the sodium hydroxide, we have to go backwards over here to figure out what's going on. So because this one, the excess hydrogen bromide and the sodium hydroxide, was a titration reaction, you can use the titration formula, but I'm not going to. I'll talk you through it without the titration formula. So now remember, the only thing we know, anything we know or are given, we need to turn into moles. So the only thing we know the moles of at this point, or can calculate the moles of, is the sodium hydroxide. So if we want to know the number of moles of sodium hydroxide, we're going to use concentration, because we've been given concentration. So the number of moles of sodium hydroxide will be equal to the concentration times the volume. So the concentration was 1/2 mole per cubic decimeter, and it said they added 16.5 cubic centimeters. So remember that you have to convert the 16.5 cubic centimeters to cubic decimeters like that. And then you will end up with the number of moles of sodium hydroxide, and it's going to be 8,25 times 10 to the negative 3 if you use your calculator. Okay, so now what good is it knowing sodium hydroxide? It's good to know the sodium hydroxide because the balanced equation, which rules them all, will tell you that for every mole of sodium hydroxide you use, okay, for every mole of sodium hydroxide you put in, it will react with 1 mole of hydrogen bromide. So if you started with 8,25 times, or if you reacted 8,25 times 10 to the negative 3 moles of sodium hydroxide, that is how many moles of hydrogen bromide must have been in the container. So this was the excess moles of hydrogen bromide, okay? And that is what is causing the pH. We're assuming that the hydrogen bromide dissociates completely. So we can say that 1 mole of hydrogen bromide is going to make 1 mole of hydronium ions, because of course we need the number of moles of hydronium ions, or the concentration of the hydronium ions, to calculate the pH. So you need to put this in as well, because remember, you might get some acids like sulfuric acid or phosphoric acid that are polyprotic acids. So once you've worked out the number of moles of acid, remember you have to turn it into the number of moles of hydronium ions. So here, if there was 8,25 times 10 to the negative 3 moles of hydrogen bromide, there will be 8,25 times 10 to the negative 3 moles of hydronium ions. Then the moles is not what goes into the pH formula, it's concentration. So the concentration of the hydrogen bromide is going to be worked out by C equals N over V. Remember to always put the formula in for the marks. So there's my number of moles of hydrogen bromide, which means it's the number of moles of hydronium ions. So this in actual fact shouldn't say the concentration of hydrogen bromide. Sorry, it should actually say the concentration of hydronium ions. I apologize. Okay, so, and then the volume. Remember it said to you, assume that the volume of the solution does not change in the reaction. So that means over here, this is still 90 cubic centimeters. So if we want concentration, we have to turn it into cubic decimeters. So there it is in cubic decimeters. And then we end up with a concentration of 0,0916667 if you put that into your calculator. And then you know the pH formula, which you must also write out. You never know which formula is going to get you a mark. pH equals minus log H3O plus. So it's minus log 0,0916667. And if you drive your calculator properly, you will end up with a pH of 1,04. So it's good to know the pH there, and that will get you your 7 marks. Now the question carries on, and it says to you, calculate the mass of zinc hydroxide. That is this right here in the beginning. The mass of zinc hydroxide initially present in the flask if the initial concentration of hydrogen bromide was 0,45 moles per cubic decimeter. So they're telling you that when they started this reaction, this hydrogen bromide initially in here had a concentration of 0,45 moles per cubic decimeter. So the first thing you have to do always is find the moles. So the number of moles of hydrogen bromide that were put in that flask initially will be the concentration times the volume. So the concentration was 0,45 and the volume was 90 cubic centimeters, which you must convert to cubic decimeters, and you will end up with 0,0405 moles of hydrogen bromide. Okay, so now why is this important? Because that's what we put in initially, okay? But not all of it reacted. Some of it went to form this excess hydrogen bromide. So if you want to find the moles of HBr that reacted, you have to go, what was my initial minus my excess? Because the reacted plus the excess will be how much you had initially. So we want to find out how much reacted. So we take the initial value that we've calculated from the concentration in the question, and we take out this value over here, okay? Because this is what we worked out from the titration reaction. So that was what was excess. So if you subtract these two, you end up with 0,03225 moles, okay? So once we figured out how many moles reacted, we can go back to this first equation over here, because we're interested in the zinc hydroxide, and the only thing we know is this hydrogen bromide. So because of the balanced equation, we can then work out what's going on here. So we need to use the mole ratio here, and we can say that 1 mole of zinc hydroxide will react with 2 moles of HBr. Okay, so if my HBr that reacted was 0,03225, this is the big number of the ratio, and this is the small number. The zinc hydroxide is the small number, so the number of moles of zinc hydroxide will be 0,3225 divided by 2, and that ends up with something like 0, what is this going to be? Okay, I can't fit it in here. 0,016125. So now once you've found those moles of zinc hydroxide, you say, what did the question ask me for? The question asked me to calculate the mass. So I'm going to scooch into here. We know if we go to the periodic table, we'll find that the relative molecular mass of zinc hydroxide is 99. I hope you know how to do that off your periodic table. So if we want the mass of the zinc hydroxide, it's going to be the number of moles times the relative molecular mass. So it's going to be this 0,01625 times 99, and this will give you a number 1,596 something. You can round it off to 1,60 grams, and there you have answered the question. The trick with these questions is to figure out which step of the 3 steps they're asking you with, and then you realize you have to work backwards from the final answer to get back to the beginning using all the steps.